ladies and gentlemen. My name is Terry Roberts. I want to present you this wind and solar hybrid project. I've worked on it for the whole semester. I did the project alone. It seems to be a two-person job, I guess you would say. On the picture here that I have on the greenhouse, this is from the company that sold us the solar panels. And it is one of the very few things that we didn't buy on it because most of it is from a part of a leftover project that Professor Andrick had me finish off another project that another person had done. In choosing the project, I see these Helix solar power units around all the time. This one here, theirs is on Jog and Roebuck Road in West Palm Beach. Mine here is in the garage, of course. I choose both. Theirs is professionally built. It's done with a model, a mold. Theirs is precise. I believe theirs costs about $10,000. Mine's home built, limited tools, limited building knowledge, limited skills. Anyway, this is the layout and development, copying the old coil and measuring for the new one. I had to do the whole new coil for the old project and do all the measuring and complete all new for the old one. And this is the project I came out with. I did the testing and recording. It does have a sine wave. It has harmonics. It does have ohms for the coils itself, which each coil comes out to about 16.3 ohms, which you know you're going to get a power supply when you have the ohms going through there. Testing and recording. I did a lot of the testing, not complete with the panels, not completely done, but they go about 20 to 30 volts. Solar controller's 20 amps. It produces about 1 volt at 50 RPMs, which has been tested at about 50 RPMs up to 200 manually without the wind on it actually. Problems and failures. The first one I did the coil. I built it with wood, and with the temperatures we had at the time were a little cool, 50 to 60 degrees. It may have affected the coils a little bit. They cracked, and they were no good. The wires inside cracked with the resin itself. The second one I did it with metal. It seemed to be a little better. Didn't warp as bad. The temperature was better. It was a little bit better job. The highlights of it, they have a small carbon footprint. You got free sun, you have free wind. People tell me a lot of times there's not much wind in Florida, but I imagine if you look, we have probably some of the highest mileage per hours of wind. I really like the course that I've taken here with the presentations, and I'm really enthused about it because it does go hand in hand with my mechanical experience. And we live in the Sunshine State. We need to regulate some new laws. Last time I saw about the solar, they had it so mixed up on the laws and the voting you can't even understand it. You know, for instance, for looks, that doesn't look good. But it does work, and you could perform better looks on it, and we need to change the laws for cleaner power and for solar. And I believe moving solar is going to be a really good for the future, and that's where I think it's going, moving solar. This picture here I took at the West Palm Beach VA Medical Center. It's very hard to see, but in the building in the middle, out of all these buildings, is one of the only buildings with solar on it. And I get a joy when I do see solar, and that's what this picture is from the VA Medical Center, looking out on the town of West Palm Beach. not much solar we can see, but we see a lot of sun. Well, thank you, everybody. Do you have any questions? Yes, I'm sorry.
Solar panels only provide DC voltage, but you also showed that you had a sinusoidal wave, meaning AC. So how do you manage between the two, from the wind and the solar, from different types of current?
Well, I made a ring gear in there, and it's a one phase, but the ring gear is made for the solar to go through there at all times. So even right now, even in the shade, it has voltage over there right now. As it turns, as the wind turns it, that's where it picks up the AC current from the coil and the magnets. And it was a three-phase unit, and I turned it into a one-phase unit for testing and practical use for easier testing.
What kind of power output does this unit make?
Well, like I said, it's doing like 1 volt at every 50 RPMs for the AC current, and the solar panels are 20 to 30 volts. But I have them wired in parallel to make it more efficient for like a 12-volt battery for charging something at 12 volt. Yes?
As it rotates, you've got wires on there. Did you have difficulty figuring out a way to keep wires from twisting up?
Yes, that's what I was saying about it. It has a ring gear made on it, and actually I cut it's stainless steel from a cooler, from like an Eagle cooler, and I just cut it to make bands, and then I put insulation in between each one and put brushes up against there so it can pick up the current voltage. Oh, is that it? Thank you.